Okay. So what is Snowflake actually? Like many of you before joining into this class, right? You would have done little research on this one, right? So what is Snowflake? Okay. So let me introduce about that. Many people know that Snowflake is a data warehouse, I would say. Like I know people are who are not from the database background. They may not be knowing this word data warehouse, I would say, but you'll slowly come to know that one as we move on. Okay, don't worry about that. Okay, I would say that Snowflake is a cloud-based data warehouse. Cloud-based data warehouse. But Shiva, what are all the other data warehouses before Snowflake came into the market? What are all the other data warehouses we have in the market? So yes, boss, we have some traditional data warehouse tools are there. Okay, those are the famous ones are Oracle is one of the data warehouse. Oracle can be used as a database. Oracle can be used as a data warehouse as well. So other one is SQL Server. Okay, SQL Server can be used as actually data warehouse and as well as database. Okay, like IBM DB2. IBM DB2 also we can use it as a data warehouse and as well as database. Like that, many on-premise databases and data warehouses are there. And one of the famous among them is, which can act only as a data warehouse, is Teradata. That was almost ruled the market for few years. Teradata, I can say. Teradata. Teradata. So, like it was almost ruling the market once upon a time as a data warehousing tool, I can say. Now, once the Snowflake came into the market, right? So, this is gone from the market. Not completely, I would say. Slowly, people started migrating from Teradata to Snowflake. Okay, see, I'm just telling the competitors here, I would say. So all these are on-premise databases and data warehouses, I would say. That means no cloud, nothing. I mean, we need to install it in a separate server and we need to start using that one. We need to start writing the queries on top of it. But Snowflake is not like that. You don't need to install anything here. It's purely cloud-based. You just need to create an account in Snowflake and start writing your queries. That's it. Okay. Nothing to install, I would say. So that is what even documentation is saying here. Let me show you that one here. Just a second. So, one second. Yeah, see here. That's what they're trying to say here. There is no hardware here. That means you don't need to install anything physically in your machine, I can say, in your computer, I can say. Okay, you don't need to configure anything. You don't need to manage anything from your end. But whereas if you want to work with Oracle, SQL Server, Teradata and all, right, you have to install something in your local and you have to manage it. Okay. And I would say nothing to do here. And administration also very easy in Snowflake. Along with the like normal SQL, administration also very easy, I would say, compared to the traditional databases. Okay. And you don't need to like follow any ongoing maintenances here. That means, let's say in Oracle case, actually, people used to use like lower versions like 11G, like 9i, 11G, 10C, like that they used to use different versions. Let's say for few years 9C, 10G is running, and after few years what will happen? Like 11G will come into the market, and after like 4 years or 5 years, 12C will come into the market. And once you start habituating to use the 9i and 10C and all, right, now again you have to like upgrade to the next versions. But here in Snowflake, we don't have that concept. The upgradation part and everything, they'll take care of everything in the back end. You don't need to worry about that one. And the management is also very easy. That's what I'm telling. The administration part is very easy here. And upgrades also they will do in the back end. You don't need to involve here. Since you don't need to install anything here, upgradation part completely taken care by the Snowflake people only. And and in traditional databases, actually, you need to have performance. You need to do performance tuning actually. But whereas in Snowflake, you don't need to do much performance tuning because Snowflake itself, okay, stores the data in a well organized format. Why do we do actually performance tuning? Because to get the results very quickly. When you run some query, actually select star from something, then you have to like get the results as soon as quickly as possible. But in Snowflake, you query something, you will get the output just like that. Because of the unique architecture of the Snowflake, I would say, and because it stores the data in the backend in a well organized format, I would say. That is only the reason actually Snowflake like standing as a leader in the market, I would say. Now, personally, I would say that I'm using Databricks and as well as Snowflake both. Querying point of view, I really love Snowflake. I really love Snowflake compared to the Databricks and other tools which I used in my experience. So if at all, if you want to query the table which is having 10 GB or 20 GB table, right, in Oracle, it will literally cry actually. But Snowflake, even if you try to query 10 million records or 1 billion records, just like that it will give. That's the beauty actually. You'll slowly understand why it is giving the results that quickly and what is the reason behind that. And you'll all go on mute, please. You'll understand all those things in going forward. Okay. Shiva, you said like you mentioned like Snowflake is a cloud data warehouse, right? Uh, like where are we going to use it much actually? I would the conclusion from this one is what I would say is Snowflake is database. Database is nothing but data warehouse. I can say we can use it as a database as well. Snowflake can be used as a database as well. Snowflake can be used as a data warehouse as well. I'll tell you the difference between database and data warehouses later. Okay. And Snowflake can be used as a ETL tool as well, but not complete ETL tool, I would say. Not complete ETL tool like your Informatica and ADF and other tools. We don't have any drag and drop mechanism here, but like I can say that Snowflake is a semi ETL tool. What are all the activities you can able to do in ETL? Almost all the activities you can able to do with SQL. Almost, not 100%, I would say, but most of the activities you can do here. That's what I would say that it's a semi ETL tool. Okay, but Shiva, can you explain like what is this ETL and how this is generally useful for us, and where this Snowflake is standing in that ETL market, and what are all the activities it can do? That's what we need to understand here. Okay, so this is the traditional ETL architecture, guys. Let me erase this one first. One second. This is the traditional ETL architecture, I would say. See, generally, why we have to learn this Snowflake and why we have to have this ETL in place, actually, ETL in the market, I would say. Let's say you have a business, you take Walmart or Costco as an example. You take better, everybody know Walmart, right? So Walmart has selling almost lakhs of products for every minute. So they have to track it. They have to track, right, how much revenue they are getting, how much profit they are getting, how much loss they are getting, which store is performing very well, and how much inventory they are maintaining, how many products they are selling per month, and all those things they have to track it actually. In order to track that, they're actually storing that data in the backend databases. If you store the data just like in the backend database, will they come to know all these? Will they come to know the revenue? Will they come to know which product they're selling more? Will they come to know who is the prime customer to their store? Will they come to know all these things? No. They have to do some analysis on top of their data. To do that analysis, we have to do these ETL activities. Okay. So what are all the different steps involved in ETL? So what we do is all these companies, data related companies, they store the data either in a database or in some third-party applications, I would say, or in web applications, or in some cloud, I would say. They can store the data in any of the place, depending on their application, I would say. Okay. Once they store all this data using any of the ETL tool, like Informatica, like a data stage is there, and like Snap Logic is there, like that. In market, many ETL tools are there. You use any of the ETL tool here. You extract the data from all these sources. Okay, transform the data as per your requirement and load the data into one of the database. This database, we call it as a data warehouse. Now your Snowflake is actually this one. Your EDW is nothing but a Snowflake here. So this is nothing but your database where you store your transactional data. Transactional data is nothing but like when you go to the like shopping, right? Let's say you're going to the Walmart and you'll purchase some products there. Let's say some groceries or fashion items or some electronic items like that you're purchasing. While coming out, actually you'll come out with a bill, right? So that data they have to store it in somewhere, right? They store it in database actually. Normal that database we call it as a transactional database. You always have to extract the data from the transactional database and do some ETL activities. Finally, store that in a data warehouse. Siva, why don't we do analysis directly on top of this database? Because you keep on inserting the data into this database, right? For analysis, actually, you need to keep on query the data. You need to keep on running the select queries. All these shops are, or I would say retail stores are keep on writing the data. On top of that one, you're reading the data from this one. If you're continuously doing those activities, your database will die. Indirectly, you're killing this database. So that is the reason why we don't do direct analysis on top of your transactional databases. We need to have separate data warehouse or database to perform that analytics. That's what we call it as EDW. The full form of EDW is Enterprise Data Warehouse. Here you are going to maintain your analytical data, I would say. Slowly try to habituate the terminology that whatever I'm trying to use here. In day-to-day life, you're going to use this terminology when you get into the project. So to do that analytics, we have to store it in a ultimately in a EDW or data warehouse, I can say. Enterprise data warehouse. Okay. The enterprise data warehouse means like in an organization, you'll be having different departments, right? Let's say if I take Walmart, right, you have like a purchasing department, you have marketing department, you have inventory department, you have let's say HR department, like the different departments are there. I'm going to store all my tables data in my EDW, in my enterprise data warehouse. All the departments tables data, I'm going to store it in EDW. Now I don't want to like see physically, I'm going to store it in all the departments data in one data warehouse only. But I wanted to logically divide this data into different, divide these tables into, logically divide it into as per my departments. Let's say HR wants to access the data from this data warehouse actually. I wanted to keep the HR related tables in one place logically. That's what I call it as a data mart. Data mart. It's a subset of the data warehouse, I can say. Okay, so we build that data marts here, like for HR one data mart, for like marketing one data mart, for finance department one data mart, and for procurement department we have one data mart. Like that, we have different data marts are there. Okay, we logically divided that. What do we do after that? See, in order to know actually, okay, ultimately, end of the day, or eventually, who is going to track your profits, losses, transactions, and all those things? Your CEO or the group leaders of the company, right? Company, right? Okay. Now, what they have to track actually? Okay, we have the data in database actually. If I give this database to those guys, hey, this is the data actually we are getting it in day-to-day basis. You go and track it. Can they able to track it? Do they have that time really? No, they're not from the SQL background, right? Why do they have to do all those things? No, we have to show them actually, hey, this is the store actually. This is the sales it has performed, and this is the profit they got actually. And this store is not performing very well. This is going in a losses from continuously from last 3 months or 4 months. So graphically, or what in a report we have to show them actually. Graphical representation we have to show them actually, so that just by seeing that they will understand, okay, which store is performing very well, which product is selling more, what is the favorite product in this particular season. Like that, all those questions will be answered by this data actually. So that is where all those activities we do in BI, business intelligence actually. So to do these activities, we have reporting tools. The best examples for these reporting tools are Power BI, Tableau, ClickView, like that. Many reporting tools are there in the market. So eventually, this is the goal actually to do to learn the Snowflake, or to enter into the data engineering field. This is what we do in day-to-day activities once you get into the data engineering field. We actually need to take the data from source, and we need to do some transformations, and we need to store it in a analytics, some data warehouse. On top of that one, we need to give that data to the reporting people. So what, out of all these activities actually, what Snowflake can do here? I know that Snowflake is sitting here. I know that Snowflake is sitting here. Apart from that, what else it can do? That's what we are going to understand now. Okay. So this is the part, this is the role of the Snowflake, I would say. Okay, as I mentioned, Snowflake is not a complete ETL tool. We don't have any drag and drop mechanism, just like you have in Informatica, Informatica or ADF, or famous ETL tools which are available in the market, I would say. But still, it can perform that one. That is the reason why, like, I'm trying to Snowflake is trying to put it hands little bit in ETL part here. And anyway, I told you, like, we are going to store our data in EDW only. On top of that one, actually, we are going to build our data mets directly in the Snowflake. Directly in the Snowflake. Okay. Not only EDW, guys, not only structural data, I would say, we can even build a data lake on top of the Snowflake. Recently, this has become very popular, I would say. This terminology itself is a popular, I would say. Data lake, delta lake. Snowflake can be used as a data lake as well. It can store the structured, semi-structured data, and even it can able to store the unstructured data up to some extent, I could say. Not completely, up to some extent, it can. It can process these unstructured data as well. Not only these activities, guys. Recently, this is what slide actually. Recently, it has put its hands in AI, ML, and all those things. One of the leader in the AI, I would say, in the market. Okay, that is okay, Shiva. Now, like, can you compare with the traditional databases here? How good it is? Like, why we have to learn this Snowflake actually? Okay, as I mentioned, right? Like, I started my career as a data warehouse database developer, right? Okay. Uh, in my experience, I worked with many of the databases and the data warehouse tools. Right. Like as I mentioned, right? Like when you try to query the data from table which is having huge volume of data, right? Literally, your traditional databases will cry. But whereas if you try to do the same thing in Snowflake, it just like that, it will give the data. Almost when you compare with the traditional databases, even when you compare with the Hadoop, actually it is 200 times faster, I would say. Querying point of view. Ultimately, like querying is most important in data warehouses, guys. Because we keep running the select queries only on top of the database. Okay, that is one point. Next one, concurrency. Okay, now I'll tell you one example here. I don't know how many of you work with Oracle database. In Oracle database, actually, if one of the let's say in a project you have multiple users. If one of the user is working on that particular database, if other user try to log in into that database, he is also concurrently or parallelly working on the database, right? Your database will start crying because it has to like serve multiple people, right? It has to create multiple threads in the backend. It has to serve all the sessions, right? It will start literally crying. But in Snowflake, you know what will happen? Even 1,000 people are also logging and trying to query the data. It will not even it can even uh, like you will not get a even small performance degradation also, I would say. Even 1% degradation also you will not find. That is the beauty with the Snowflake, I would say, because of its architecture. I'm going to discuss about the architecture also now today only. Concurrently, even 1,000 people are also like trying to log in and querying. It can answer every query. It can execute concurrently. That's the beauty. Okay. And elasticity, as I was mentioning, actually, okay, as I was mentioning, to execute all these queries, actually, we need to have some execution engine, right? I'll talk about that execution engine also a bit later. Okay. Uh, in that execution engine, as the number of users are increasing, okay, number of users or number of people who are querying the data are increasing. What will happen? You can increase the compute power to up to 6x large, I can say. You will understand what is that 6x large later, not now. After few classes, you will understand that. That means almost 1,024 systems will work for you to execute your query, I can say, the backend. Up to, I can say, not every time, up to. Okay, that is the beauty with the Snowflake, I would say. You can scale up the hardware up to 6x, up to 1,024 systems. But in traditional database, actually, only one you'll install only in one data, only one system, I would say. Only that system will work to execute your queries. But here, 1,024 systems are working for you. Readily available. 1,024 systems are readily available, actually. This is the max number, I would say. Okay. And no configuration at all. No, nothing. You don't need to install anything. When you compare with the traditional databases, I can say, let's say I have a server. If I install it, if I install my database in a server, right? You need to put that server in a room, and you need to maintain some cooling fan for that room. You need to continuously maintain internet for that. You need to maintain continuously power supply for that. Do we really need to maintain all those things for Snowflake? Do we need to provide the internet to the Snowflake? Snowflake itself is a cloud, right? Why do we need to give all those things? Do we need to give continuous power supply to the Snowflake so that it will be live? No, it's a cloud. It's purely cloud. So we like if you have any higher versions or upgradation versions, right? Do we need to upgrade them? No, not required at all. Snowflake will take care of all those things actually. It is very simple, easy to manage, I would say. And one more thing, if you want to become a master in Snowflake, I would say, you don't need to learn any special skills. Hardly you go with the SQL, that's it. And little bit of Python, I would say. Python is required. I used to say Python is optional for till my last batch. Now I'm saying that from this batch onwards, Python is mandatory to get into the data engineering field. It's mandatory, I would say. You go and search in any job portal, you search data engineering jobs, definitely 90% of the jobs, they'll ask actually one of the mandatory skill is Python. The usage of Python is extensively increasing day by day, I would say. So to become a master, I would say SQL is enough. To survive in the market, actually, Python is also required, I would say. Okay. If you already have one programming knowledge, that is super. Okay. These are all the advantages, I would say. Okay. Now moving on, let's get into the architecture part, guys, actually. Okay. Now let me go to the documentation. Now in the entire course, I'll walk you through the documentation only. I'll explain everything in the documentation only. Okay. I'll not follow any of the third party website or blog. I'll simply come to the documentation and I'll try to explain everything here. So they have given beautiful documentation. Special website is there for the documentation, that is docs.snowflake.com. Even while once I explain the concept, right, you guys also have to go and refer this documentation only. Don't follow any other video, don't follow any other blog, don't follow any other third-party websites. No, simply go and like start reading the content from the documentation so that it will be helpful in your certification exam clearance, and it will increase the subject knowledge actually. Whatever they have given in the documentation, that is truth. That is true. 100, the information, whatever they've given in the documentation, that is 100% true. But if you follow third-party websites or blogs, right, they may give sometimes false information as well. But once you start following this one, you'll improve your subject in different way, I would say. Okay, start following this documentation. Okay, now this is the architecture of the Snowflake, guys. Okay, Shiva, since you said it is a cloud, actually, where do they maintain? Where do they store the data? Actually, where do they store the data? Yes, remember one thing. Even though Snowflake is a cloud data warehouse, they do not have any dedicated data centers. See, if you want to store some data, you need to have data centers in the backend, right? Correct or not? If you want to store the data in a database, you need to have some server. There you need to install your own database. But where did they install all these databases in the backend? No, they don't have any dedicated database. They don't have any dedicated data center in the backend. But how come they're storing the data over here? They are depending on sorry, they are depending on public clouds. Who are they? The first one is AWS, Azure Web Services. Sorry, Amazon Web Services. I'm sorry, my bad. Amazon Web Services. And second one is Azure. Third one is GCP. They're completely depending on these three public clouds. Okay, where they are storing this? Where they are storing the data, Siva? In AWS, we have the storage service called S3. Okay, in Azure, we have storage account called Blob. In GCP, we have GCP bucket. I would say this is bucket, GCP bucket, Google bucket, I would say. Okay. So Snowflake is actually storing your data either in S3 or Blob or GCP bucket. They're completely depending on these three clouds. Even when you try to create a Snowflake account, actually, they'll ask you, hey, which cloud you wanted to store the data, or which cloud you wanted to take the resources. I'll show you that one tomorrow. Okay. So that is actually database storage layer, I would say. Basically, we have three layers. First layer, I would say, is the database storage. What I would say here is Snowflake does not have any dedicated database and they don't have any dedicated data centers. They're depending on the public clouds called AWS, Azure, and GCP. And that too, they're storing in S3, Blob, and buckets. Indirectly, your Snowflake is storing in these three buckets actually. That depending on the cloud that you choose. While creating an account, if you choose AWS, indirectly Snowflake is storing their data in S3. If while creating an account, if you choose Azure as a cloud, then they're storing your data in a blob. If you are creating an account with GCP, they're storing your data in GCP bucket. So in order to create a Snowflake account, you don't need to create a account for AWS, Azure, or GCP. They will create an account in the backend and they'll try to store that data. You don't need to worry about that. You just need to create an account with the Snowflake. That's it. That backend things they will take care. Why do we need to worry about that? That is about the data storage. Okay. Now, once you store the data, you need to query it, right? Actually, ultimately, whether it is a database or data warehouse, you need to query the data, right? Now, how do you query that one? In order to query the data, you need to have some compute power, right? Absolutely required. So that compute power is nothing but a virtual warehouse. Okay. Now, what is this, Shiva? Okay. At least, Shiva, do they have these virtual warehouses in their, like in the Snowflake account? I would say no. This compute power also, for getting this compute power also, they are depending on again on clouds. Indirectly, when you create a cluster to execute your query, they are indirectly creating a virtual. Here in AWS, we call it as a EC2 nodes. In Azure, we call it as a VM. In GCP, we call it as a VM. Indirectly, backend they are creating these VMs and executing your queries. That's what we call it as a virtual warehouse. Your query is actually processed in this layer. Your data is actually stored here, but your query is processed here. Processed means once you apply, let's say, select star from EMP where department number equal to 10. Department number equal to 10 means it has to be filtered, right? That filtered conditions, aggregations, and everything will be performed in this layer only. That is the second layer. Okay. Now, I'll try to interlink these two layers here. Shiva, how much data we can store in this layer here? 1 TB, 10 TB, 100 TB, or 100 petabytes of data? How much we can store? Boss, there is no limit. There is no limit. You can store unlimited data here. Nobody is going to stop. You just need to pay a rent for them. How much you're storing? How many terabytes of data you're storing per month? You just need to pay rent for them. That's it. That rent also cheap, I would say. Very cheap. Hardly for 1 TB you're going to pay per month, you're going to pay $24. $24 hardly. 24 to 40, 45 hardly, depending on the plan that you choose. how you have the postpaid plans, right? In the same way, here also we have plans. The minimum to minimum, you're going to pay 24, maximum you're going to pay 45. Of course, that depends on the region and the cloud also. I'm going to talk about this one later, not now. Okay. Shiva, let's say for my requirement, I'm going to store 100 TB of data. Of course, you store it. Who stopped you? Okay. Since I'm okay, in future, I may get actually 200 TB requirement. Yes, take it. How much ever you want, you take it. Since I'm keep on increasing the storage here, do I need to increase the virtual compute power here? No, not really. You don't need to increase that. This layer and this layer completely decoupled. That is what I was telling actually. It's unique architecture. Because of this unique architecture, it has become very popular in the market and it is executing the query with queries in a just like that within seconds. Only because of this architecture. Only because of this decoupling concept, I would say. But in traditional databases, if you want to increase the storage, you have to increase the server capacity. That means indirectly you're increasing the compute power also. But here in Snowflake, you don't need to do all those things. Okay. And the next third layer is cloud service layer. In the third layer, sorry guys. Okay. So this is indirectly virtual machine, right? Let's say I've chosen actually AWS as a cloud in the backend. Okay. Indirectly, this is an EC2 node. Indirectly, this is an EC2 node. Okay, let me erase all these things. Indirectly, this is an EC2 node, and this is a S3 bucket. Okay. See, Snowflake is a third-party company, right? Snowflake is an independent company, right? They have to manage this EC2 node and S3. These are all one of these service in AWS, right? EC2 node, EC2 is a separate service in AWS. S3 is a separate service in AWS. Backend, your Snowflake has to manage all these services, right? These services are completely managed by infrastructure manager. Okay, 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 Shiva. Shiva, I'm writing one query to execute. Okay, let's say select star from EMP where department number equal to 10. That is what the query I've written. How does your Snowflake know that the query is syntactically correct or not? Somebody has to validate that in the backend, right? That validator is nothing but optimizer. Backend, it has to generate logical plans and physical plans to execute your query. The optimizer is going to take care of all those things. Okay, you're storing the data where actually in S3 bucket, right? Indirectly, you're somewhere some remote location you're storing that data. Let's say you're storing the data in employee table. That employee table related metadata somewhere they have to store, right? Okay, the table is employee and the columns are like employee number, employee name, salary, commission, department, all those columns are there. Somewhere it has to maintain that metadata, right? That metadata is maintained by metadata manager. Okay. If at all, if you want to, let's say in my project, 10 people are there. All 10 people actually have to work parallelly. Okay. So that once you get into the project, they'll actually create a username on behalf of you and they'll ask you to start working on it. So something we have to start creating the users and giving the permissions to the tables and managing the administration is completely managed by security service. Okay. Once I create the Snowflake account, you'll give username and password, right? Somebody has to validate that username password correct or not, right? That is going to validated by authentication and access control. Okay, what I would say is all three layers are independent to each other. That is the beauty in Snowflake. If you keep on increasing the number of users, you don't need to increase the storage, you don't need to increase the compute power here. All these are independent to each other. Any number of virtual, we can increase the size up to 6XL here. You can have the data, you can store petabytes of data in the storage. You can create any number of users here, no problem, irrespective of the storage and compute power. Okay, so this is about the architecture part. In any interview, in every interview, they'll ask this question actually. Hey, can you explain this Snowflake architecture? You have to talk about all these points.
There are two questions here. So
Yeah.
first one, since S3 is a file system,
Mm-hmm.
but to store the data, we are talking about database.
Mm-hmm.
How file system and database are related, and
Mm-hmm.
moreover, using the SQL query, how can we get the data from a file?
Okay. Okay. Good question.
So that
Okay.
is first one,
See,
and
yeah.
second one,
Mm, mm,
and
mm,
second question,
mm,
since these three layers are independent
mm,
and without the query processing layer or EC2 instance,
mhm,
so how can we access the data
mm,
without
mm, mm,
any
mm,
like
mm.
computer or resources?
Yes. See, front end you have an application, right? Front end you have UI. UI will take care of all those things to connecting to this virtual errors, to connecting to the database and all. Once you create an account, they'll create UI right for you. I mean, not only for you, for everyone, right?
Yep,
So
yep, yep.
that UI will take care of that one. Back end they have that algorithms, right? Actually, running in the back, running behind the curtain. That they will take care
Yep.
of that one. You don't need to worry about that one, right? Back
So
end, that logical correction, they will establish it.
okay, okay. Basically, I'm trying to understand in a way that
Uh-huh.
if they maintained
Mm,
independently, what is the
mm.
use? Because ultimately,
Independently,
when
in the sense, like, okay, once you create an account, they will not have like link with this one. They will not have link with this one. I don't mean like that actually. I don't mean like
okay,
that.
okay, 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 got
My
it.
meaning is actually, my point is actually, if you want to increase the storage, you don't need to increase the virtual arrows here. That means they are independent to each other, right? They're not
Yes,
dependent
yes,
on.
got it.
They're not depending on each other, right?
Yeah, got it, got
If
it.
you want to increase the like number of users, actually, do we need to really increase the virtual resources or storage here? No, not really required. In that way, I'm telling all these three are independent.
Okay, yeah. It's
Okay.
about capacity increase, not about connection.
Yes. Not about the connections here. Okay. To answer your first question, what was your first question? I forgot. So I'm sorry. Again, I'm
So
asking.
when
Uh,
when we talk about the
okay.
database
Okay. I
storage,
got it. Yeah. When you store the data in a or like an S3 bucket or blob, right? You're actually storing your data in a files format, right? How come you're calling it as a database? So do you know? I don't know whether you are a database background or not. Even Oracle also backend stores the data in a file format only. Even your SQL server also backend stores the data in a file format only. When you do select star from some table, it will go and like actually query the data from these files. But you will not able to see these files actually. The same way, Snowflake also following. They have special concept called micro partitions in the backend. Your data will go and sit in that micro partitions. So when it do select star from some table, it will go and actually fetch that data from the micro partitions. That is not your headache. That they will take care. That is what for you're paying, right, for them. Did I answer
mm,
did I answer your
yes,
question?
yes, yeah, yeah, yeah.
See, ultimately, you take any database in the world, back and it has to store in a file format only. You take anything, you name any database, backend is file format.
Okay, got it.
Okay. Okay. Now moving on. Any other question for anyone? Okay, I'll answer your questions. So whoever is posted it in chat. Okay. At the end, I'll try to answer all those questions. Okay. Now next. Mm, ah. So I told you right already. Instant on the compute warehouses are instant. If you want to execute, if you have decided to execute something, just like that, you can execute it. Instantly you can execute it. You don't need to wait in the backend to spin up the virtual machines or to spin up the EC2 nodes and all. No, your Snowflake is making them available always. That is what they're saying. It as instant and almost unlimited scalability. Don't ask me unlimited means we can spin up any number of clusters here. No, it's not like that. Maximum 6x clusters, 1024 systems you can spin up. That's it. Not more than that. Even guys, even if you're trying to get like a 1 GB of data or 1 terabyte of data from the table, actually maximum one or two systems are more than enough to handle your large volume of data. They have given up to 1024 systems capability or capacity, I would say. Think like this. To handle petabytes of data, only two systems are enough. What if they've given us to use actually 1024 systems? How much volume of data we can manage? We can handle, I would say. Okay, that is what they're saying here. Indirectly unlimited here. Now, directly unlimited means I know some people say that, okay, we can create n number of clusters here. No, it's not like that. That doesn't mean like unlimited doesn't mean like that. This is one of the good feature in Snowflake, I would say. Okay. And one more reason why Snowflake has become very popular, it can integrate with any of the ETL tool, I would say. It can integrate with any of the reporting tool, any of the ETL tool, I would say. You name any ETL tool in the market, Snowflake connection is there. Definitely. 99% I would give guarantee you'll have connection. If they don't have connection in that ETL tool, they're not, I would say that they're not up to the market standards. It can integrate with any of the tool. That is also one of the beauty. Okay. Now, when was it came into the market, Shiva? Initially, they tied up only with the Azure, Amazon Web Services, AWS case actually. Initially, they came into the market only with the AWS back in 2014-15, I would say. Slowly they came into the market. And later on, Microsoft Azure also is becoming very popular and started grabbing the market, started increasing their customers in the market, I would say. Then they they started slowly tied up with the Azure as well. And they came into the market with Azure in 2018, recently only, hardly 6 years back only, hardly 6 years back. GCP very recently they came. GCP. That is the reason why even if you get any new feature, actually they'll first launch in AWS. Yeah, the people who are using AWS cloud right in the backend, they can able to see that services first, the features first. Okay, that is one thing. And Snowflake can support actually all the file formats, guys. Structured formats it supports. It can process structured files. It can handle actually semi-structured files. It can handle even up to some extent unstructured files as well. Because in even in Snowflake also, people started using Python. Snowflake has given that connectivity. Snowflake has given that feature actually. You can start writing your processes in Python. You can start you can start your writing your transformations in PySpark, Python plus Spark, directly in Snowflake. So because of that extendability, because of that Python introduction, Snowflake started supporting even unstructured files as well. Okay. And I told you right already, like you can increase the at any point of time, you can increase the size of the virtual arrows. One cluster, second cluster, third cluster, or if at all, if you want to schedule that clustering, right, you can happily schedule that. You can happily increase at any point of time, I would say. Any point of time, you can increase it. They're readily available in the backend. You don't need to wait until they spin up. That is one of the beauty. Okay. One of the famous feature, in like Snowflake, data sharing. I have downstream consumers actually who are actually trying to consume the data from a Snowflake. Then how do I share them? How do I share the data with them? Are they also having Snowflake account? In that case, you can still share the data with the other Snowflake accounts within the organization or outside of the organization, I can say. That is also one of the good feature, I would say. Okay. And as I mentioned, right, like if at all, if you want to replicate the data, replication means data. I've created one Snowflake account here. Let's consider the data they are storing in one particular data center. You wanted to maintain high availability on top of your data. I'll talk about all these high availability and all later. Okay. You wanted to maintain high availability. If you want to maintain actually that high availability, you can replicate the data from one data center to another data center, one Snowflake account to another Snowflake account actually. That is also one of the features they have given. That means what they're saying is at any point of time, your data is fully safe. There is no chance of going like down. There is no chance of like losing your data. Almost the chances are 0.000000001%. Because of this feature. Okay. And one more thing, as I mentioned, you don't need to have any special skills to become a master in Snowflake, I would say. So what are all the like SQL commands in traditional databases, right? Those are more than enough to handle this Snowflake. Everything is supported here. Everything. Okay. Yeah. So I was just trying to mention at a high level all these features, guys. Now, once we start like get into the subject, right? We'll try to understand all these features deeply one by one. Okay. Now I'll stop recording the session and I'll try to discuss about the course content and all here. Hold on.